Hey there! This video is going to help you with solving radical equations. So I just have 4 quick examples here I'll work through. These are from the notes on, I believe, pages 8 and 9. Okay, so the first thing we want to do is, here I'm going to write it down here. The first step is always to isolate the radical. So I'm going to add 5. Okay, now that my radical has been isolated, I'm going to square or cube, raise each side of the equation to the power that's the index. So since this index is 2, I'm going to square each side of my equation. Okay, so the reason we do that is because the square root and the square are opposite functions, opposite operations, and so those kind of cancel, so you can cross them out if you want to, and we're just left with what was the radicand, what was on the inside. And then 5 squared gives me 25. So from now it's just solving for x. So this just becomes a normal algebra problem, I guess. And we get x equals 6. So the last thing we want to do with these is check to see if it's a valid answer. Because some of these solutions could be what we're called extraneous. If when we square each side, sometimes that will lead to a solution that's not actually correct. So to check it, we are just going to plug it back into our original equation. So for x, I'm plugging in 6 plus 1 minus 5 equals 0. So I get 24 plus 1, which gives me 25, minus 5 equals 0, and I get 5 minus 5 equals 0, which is correct. So that is a valid solution. All right, this next example here, again, I want to start by isolating my radical. Now that I have that isolated, I'm going to take the power of each side. Here my index is 3, so instead of squaring each side, I'm going to want to raise each side to the 3rd power, or cube it. So again, the radical and the cube cancel, so we're left with just 2x minus 7 on the left side, and then we get negative 3 cubed. You can type that into your calculator or think about it as negative 3 times negative 3 times negative 3, which would leave us with negative 27. And now we're just solving for x. And I get x equals negative 10. So now I need to check if this is a valid solution. So I'm going to take my original problem and rewrite it with my x plugged in. So simplifying this, I get negative 20 minus 7 plus 2 is negative 1. The cube root of negative 27, which is negative 3 plus 2 equals negative 1. All good there. All right, looking at this one, again, we want to start by isolating the radical. So I'm going to subtract first. And then I'll notice here this 5, that's not the index, it's a coefficient of 5. It's being multiplied, so the opposite operation would be to divide each side by 5 so that those cancel. And I get square root of x equals 2. Now I can square each side. So I'm left with x equals 4. And then we go to check it. So I have 5 square root of 4 plus 2 equals 12. So the square root of 4 is 2. And then order of operations here, 5 times 2 is 10 plus 2 equals 12. That is going to be correct. All right. last one here, isolate that radical. Now that it's isolated, the index is 2, so I'm going to square each side. And then I'm going to divide. And last but not least, I always have to check that answer. Plugging it back in, 4 times 9 plus 2 equals 8. Okay, so the square root of 36 plus 2 equals 8. 6 plus 2 equals 8. Awesome. I'm going to have us do one more problem. So solving this, I notice my radical's already isolated, so I'm going to start by squaring each side because the index here is 2. I get 2y plus 1. Negative 3 squared, be careful with the negative, it's negative 3 times negative 3, which is positive 9. So then when we keep working, we will find that y equals 4. So now I can check my answer. Plugging in 4 for y. So I would get 8 plus 1, which is 9, and the square root of 9 is 3. Uh-oh, this is a problem because it's not the same. So what we notice happened right here, that negative 3, well, when we squared it, it became positive 9. So sometimes when we square or cube, whenever we take the power, it's going to lead to extraneous solutions. So you still want to solve the problem because you don't know if it's an extraneous solution. And you won't know until you check it. So solve the problem, see what you get for the variable, plug it back in, and then when you see that it's different, what we can say is y equals 4 is an extraneous solution. So it is not a valid answer, a valid solution for this equation. But on a quiz or test, we might ask you, to explain what this solution is. So you would say that it's an extraneous solution. Great job, everyone.